Hey everyone, and welcome back to Blue Sono TV, the show where we make audio technology simple, clear, and fun to understand. Today we're diving into a topic that confuses a lot of people: bit depth in audio. You've probably heard terms like 24-bit audio, 32-bit floating point, and dynamic range, but what do they actually mean? Do more bits really mean better sound? Let's break it down, step by step. Let's start with the basics. When we say 24-bit audio, we're talking about how finely we can measure volume. A 24-bit ADC, that's short for analog to digital converter, takes your incoming audio signal and splits the volume into over 16 million tiny steps. That's 2 to the 24th power, or exactly 16,777,216 levels. It's a decibel value of what 16,777,216 is. These levels are used to represent both the positive and negative sides of an audio wave, because sound is a wave that moves above and below zero. If you do the math, 24-bit audio gives a theoretical dynamic range of 144 dB. That's a huge range from the quietest whisper to a thunderclap, but is that what you really get in practice? Here's where things get interesting. That 144 dB number, it's just a theoretical maximum. It's what you'd get if your converter was 100% perfect. No noise, no distortion, no electrical interference. But in real life, even the best 24-bit converters don't get close to 144 dB. Most high-end ADCs land somewhere between 110 and 126 dB of actual dynamic range. Why the gap? Because analog electronics aren't perfect. You've got noise from parts, circuits, power supplies, grounding, and even temperature changes. All of that limits how cleanly the signal can be converted. So while the digital container, the 24 bits, is large, the actual analog performance is what decides how much of that container gets filled with real signal. This is why engineers talk about ENOB, or effective number of bits. It's how many bits are truly being used after factoring in noise. Now let's talk about 32-bit floating point, because this one causes a lot of confusion. You might think, well, if 24-bit gives me 144 dB, then 32-bit must be even better, right? Not quite. 32-bit floating point works differently. Instead of using all 32 bits for signal detail, it splits them up. 1 bit for the sign, positive or negative, 8 bits for the exponent, control scale, and 24 bits for the mantissa, holds the actual signal detail. That seems it has more the real detail, or resolution, but is about the same as 24-bit audio. Just a more bit for the container size. So you're not getting more sound quality, you're getting more flexibility. Here's what makes 32-bit floating point special. It gives you a much bigger container for calculations. You can record or process very quiet or very loud sounds, even if they go over 0 dB, and the system won't clip or distort. This is because 32-bit floating point gives you what we call calculation headroom. Extra room for processing, not extra analog headroom. Important note, this is different from audio headroom. Audio headroom is about avoiding clipping in analog gear, but calculation headroom is about letting your DAW or plugins work freely without distortion or rounding errors, even when levels go outside the usual range. So if you're recording a 24-bit signal and storing it in a 32-bit floating point file, you're not getting better audio. You're just giving it more space to be processed safely. Most of the extra bits, they're just zeros until you start mixing or editing, which will add data. Let's wrap it all up. 24-bit audio gives you a big container, but how much of that container gets used depends on the quality of your analog hardware. Better converters give you better use of those bits. 32-bit floating point doesn't give you more detail, but it gives your DAW and plugins more freedom to do processing without problem. But here's something else to remember. Listening to audio above 100 dB SPL for a long time isn't just unnecessary. It's actually dangerous for your ears. That means for real-world listening, even less than 100 dB of dynamic range is usually more than enough. Yes, more bits give you more resolution, and that's great for recording and mixing. But it's better to go with 24-bit for the audio signal itself. More bits for processing, like in 32-bit floating point, is always welcome, but for capturing the audio signal, 24-bit is usually enough to avoid clipping and preserve quality. So, don't be fooled by the size of the container. The quality of the source audio along with the ADC and DAC quality is far more important. Focus on good recordings, good gain structure, and let the music speak, not just the math. Thanks so much. We hope this helped clear up what 24-bit and 32-bit floating point really mean in audio. Remember, it's not about chasing the biggest numbers. It's about understanding what they really do. If you liked this episode, please subscribe. See you next time.